Hi everyone, this is Maverick Phua, the Chemistry Guru. Now in this video, we want to go through the basicity of organic compounds. Now for organic chem, usually the concept for us to explain basicity is usually using the Lewis acid-base concept, where our Lewis base is a lone pair or an electron pair donor. So therefore basicity in organic chemistry is actually fairly straightforward. We just focus on the lone pair availability. Now in organic chem, all the bases that we have are nitrogen compounds, so it becomes a very straightforward issue of just focusing on the lone pair on my nitrogen. If the lone pair on my nitrogen is more available, then it makes it a better base, a better Lewis base. Now if the lone pair is less available, then it makes it a weaker Lewis base. So let's take a look at the comparison between the basicity of different nitrogen compounds. Now the trend that we have is basically here. So what we notice is our tertiary amine is the most basic functional group as compared to a secondary amine, a primary amine, and then followed by my ammonia. Now, you will notice the number of R groups actually affect the basicity. So this one is explained using our electronic effect, which is related to the number of donating or withdrawing groups attached to my function group. And so therefore it affects the reactivity of that functional group. Now what we notice in this case, our phenylamine is less basic than ammonia. So later we will talk about this using the resonance effect. And our amide is less basic than phenylamine. In fact, our amide is neutral, so it actually doesn't function as a base, and the nitrogen doesn't donate a lone pair. So later we'll also be able to explain this using the resonance effect. Now the electronic effect is fairly straightforward. Because R group is a donating group, so what R group will do is it will push electron to my nitrogen, so it will increase the lone pair availability on my nitrogen. So the more R groups we have, and therefore the more available the lone pair will be on my nitrogen, and it make it more basic. So the more electron donating groups we have, so nitrogen becomes more electron rich. So the lone pair on my nitrogen becomes more available for donation, it makes it a stronger base. So if I compare a tertiary amine, we have more electron donating groups, 3 R groups that's pushing electrons to my nitrogen, so the lone pair is very available for donation. Whereas if you look at ammonia, because it doesn't have any donating group, so the basicity in terms of ammonia as compared to my amine will be weaker. Okay, next, if I look at phenylamine, what we notice in this case is my lone pair on my nitrogen is delocalized into my benzene. Now benzene has this delocalized pi system. This orange ring here is the delocalized pi system involving benzene. So what nitrogen would do is it would use the lone pair to interact with this delocalized pi system, and because it has to spend some time to interact with this delocalized pi system, the lone pair becomes less available for donation. So we can say that the lone pair on my nitrogen, because it's delocalized into the pi electron system of my benzene, so it's less available for donation, so it makes it a weaker base as compared to ammonia. Now for amide function group, it also has this delocalization, but it's delocalized into the acyl group or the acid group. So what this means is effectively the lone pair on my nitrogen actually can move away from nitrogen and towards and into my oxygen. So therefore, the lone pair is actually delocalized very well between my nitrogen, carbon, and my oxygen. One way we can do is we can show using this structure here, where this curve will represent the delocalized lone pair, and this lone pair is delocalized very well between my nitrogen, my carbon, and my oxygen, because oxygen is very electronegative and nitrogen is also pretty electronegative. So the lone pair is actually spread out very well between the two electronegative atoms. So because the lone pair on my nitrogen is delocalized extensively between the electronegative nitrogen and oxygen, we don't use it for donation. Amides actually don't use the lone pair on my nitrogen at all for donation, so therefore amides are neutral. I hope you find this video lesson useful. If you like it, please give me the thumbs up, like this video, and share it with your friends. Now for more video lessons, please subscribe to my YouTube channel. If you have any questions or concepts that you want me to clarify, please put them at the comment section below so that I can address them in future. Thank you for watching. I'll see you next time.